Hello everyone, this is my assignment for real-time rendering module. Here I have implemented a shadow volume algorithm to create the shadows. So in the output you can see sharp edge shadows. Um, this shadow volume algorithm is implemented using the depth fail test. Mm, so yeah, this is the output. So let's look at the code now. So here is the main function. So the shadow volume algorithm is implemented mainly in 3 steps. So before starting, the main thing is we clear our stencil buffer and color buffer and depth buffer to 0. So here we are clearing the buffers, and for the first step, we'll first disable the stencil test because we are so the first step is basically we render the scene normally using the depth buffer, but we are not so here I've enabled the depth test but disabled the stencil test. So we just render the scene normally, and yeah, and so we render the cube and then the plane, and then in the second step we actually create the volume for the shadow, and then we calculate our stencil buffer accordingly. So the volume is created in the geometry shader. We'll look into that in a minute. So here we set the color mask to false because we are not actually getting any color from our fragment shader. We don't want anything. So, and depth mask as false, and we enable the depth clamp. So when we create the volumes, we first detect the edges of the object, and then we cast the edges to infinity to create a volume. But in practice we don't do that till infinity. So we want we want the volume till the maximum depth possible. So this function clamps the volume to the maximum depth possible, and then we clear our stencil buffer again, and we enable our stencil test. And this is a very important command here, stencil function gl always. So we set as gl always, so it will always pass the stencil test because we want the values, stencil buffer values, for every single pixel. So here it is passing all the tests to store the values in stencil buffer, and then we use our shader for to create the volume to create the volume. So let's look at the shaders here. So this is our vertex shader. Here we give the position. So here we give out the position of the vertices, and then in the geometry shader we actually calculate our volume. So here we're taking the vertex positions as input vector. So this is and then we so this is the function defined to calculate the edge quads. So it will emit the vertices to create the edges of the volume. And here we are only considering the triangles which are facing towards the light. So this if condition is satisfied, then we'll calculate all the volume, otherwise we don't bother about it. So and so here in the front cap is calculated, and with a slight deviation here. So we are using deviation with multiplying by epsilon. This epsilon is giving very small values, 0.01, and this is due to because of the floating point errors. We move the front cap triangles slightly along the light direction vector. So and for the back cap we just simply reverse the order and emit the vertices. So after calculating the front cap, we calculate the back cap, and in the main function we actually clamp them. One important thing here is the maximum vertices here. So here the maximum vertices is set 18 here, 3 for the front cap, 3 for the back cap, and 4 for each of the silhouette edges. So from every triangle face edge, it will create quadrilateral, and we like for each quadrilateral we have like 4 vertices, so it sums up at 18. And here we calculate our volume for the shadows, and then we go to here. Then we'll disable our depth clamp after the end of the step 2, and we set the color marks also true, because in the third we actually want the colors from the fragment shader. And we disable the depth test also, and now here we are setting the GL stencil function as GL equal, so that the only and equal and then 0, so only the values which have stencil buffer value as 0 are considered for the rendering. And then we render our scene here again to get the shadow output. So this is the algorithm for shadow volume algorithm. Thank you.